Hi everyone, I am Ping Chen, and we are from National Yangming Jiao Tong University. Today I will present our paper, Self-Attentive Recommendation for Multi-Source Review Package. And first, I will introduce this problem, and I will define what is the multi-source review package. And let's see the picture in this slide. It is the screenshot from a hotel booking website called Trivago. So when we search some hotels in this website, we can see the information about these hotels and also the price. We can also see some reviews that comes from the other website like Yelp or Google or Expedia. So we can say that it is the multi-source review package. But why should we recommend the multi-source review package? It is because some researchers have demonstrated that collecting information from multiple sources is more desirable, since it can provide more information than a single source. So the problem is a little bit different from a traditional recommendation. We want to predict whether this user would feel useful or not about the review package. But there are some challenges about this problem. So first, we have to learn the user's preference on the review sources. And the other problem is that reviews in the same package may be conflicting to each other. Like the example here, the two reviews from Expedia are conflicting to each other. You can see one is positive and the other one is negative. So we will introduce some related books about the problem. And the first one is called Bundle Recommendation Problem. And the bundle recommendation is to provide the user a set of items. And it is similar to our problem since that we want to recommend a set of reviews. But most of the work about bundle recommendation is to learn a bundle feature, and they will predict the user's preference about the bundle. This problem failed to capture the interaction inside the package. And the other related work may be factorization machine-based model. And this kind of model is very popular in the context-aware recommendation, since it computes the inner product of about each pair of the features. So it can learn the mutual interaction about each pair of the features. But this kind of model is failed to capture the information about a whole package. So due to the problem mentioned above, to solve the multi-source review package recommendation problem, we designed the new model here. And this is the model framework. So we use two self-attention modules to learn the interaction inside the review package, and also the interaction between the user and the package. So in the left-hand side, we can see the enhanced feature comes from the self-attention module. So we will do pooling about the package feature and pooling about user feature and do concatenation. So after we fuse these features, we use the MLP to predict the overall usefulness. And we also want to predict the reviews in the package is important or not. So we say that it is the inversibility prediction. The inversibility prediction may help the usefulness prediction here. And let's see the detail about the model. This is the first self-attention module, and it is to learn the pairwise interaction inside the package. And the review feature may consist of the source feature and also the rating information. So after we do self-attention computation, so we can get the enhanced package feature here. Then we will do another self-attention about the enhanced package feature and the user feature. So the user feature may consist of the user behavior, or we call the user's intention or the purpose. And we can also get the user profile information, and we compute the other self-attention about the user feature and the package feature. We add a mask here since we want to focus on the interaction between the user and the package. So here we got the overall enhanced feature from the second self-attention module. So after that, we get the overall enhanced feature. Then we do pooling about the package feature and pooling about user feature and do concatenation. And then we use 2 MLP to predict the usefulness and the inversibility. So we optimize this model, use the loss function in mean square error about usefulness and the inversibility. So after we introduce our model, then we use 2 data sets to evaluate our model performance. Since there is no public data set about this problem, so we collect a new data set called multi-source review package data set. And it consists of reviews about some restaurants. The reviews here may come from Google or Facebook, news media, or local guides. And we can also see the content or the text about the reviews and also the rating. So here we ask the user to answer their overall usefulness about the review package and answer whether the review here is important to them or not. And it is some analysis about this data set. So we can see this pie chart. So about 23% of people like the conflicting rating. And so we think that it is still important to learn the interaction about reviews in the package. So here we show the experimental results about this data set, and the score is in mean square error. So the lower is better. And our model is in the last line. And we compare our model with some factorization machine-based model. So the baseline in the previous 5 lines all about factorization machine-based model. But it seems that this model is not able to capture the package feature in this data set. Okay, so we also want to demonstrate that our model can really capture the item interaction in a package, and we can also solve the real-world problem. So we test our data set on the other public data set called Trivago. But the data set here is different from the example in the previous slide. And this problem is to predict the user's clicked-out items from 25 impressions. So we can say the problem is that when the user search some keywords in this website, and the search engine will return 25 results about the keywords. And now we want to predict which one in the 25 impressions will be chosen by the user. So the data set consists of many section blocks, and the square here means the section action, like interaction with some items, like the interaction with image, or select a filter, or search something. And the cross sign here is named the clicked-out item. So we can see the section block data. The user may do many actions before they do clicked-out item. So this action here may help us to predict the user's intention, and also help us to predict the clicked-out items. So here I draw a very simple example to illustrate this problem. So suppose that the website may shows the 25 impressions here, and suppose that the user will click the third item in the 25 impressions. So we will rank these 25 impressions. And if we rank the third one higher, we can get the higher mean reciprocal rank in the upper left side. So the higher MRR score is better. So here we show the experimental result about this data set. And the baseline here are still factorization machine-based model, but we use two different baseline here. These two baseline, they consider the historical record about the user. But it seems that they still cannot find the information inside the package, so it's still not performing so well here. So the conclusion is that we formulate a new problem called multi-source review package recommendation, and we also propose a new framework to solve this problem. And at the end of my presentation, we also evaluate our model in two data sets, and we show the model's performance. Okay, and this is the end of my presentation. Thank you for listening.